Hello. This video here is about the Protactinium-234m generator. This is a Protactinium-234m generator that I built, and I used hydrochloric acid concentrated. You can see it here in the bottom phase here. Up here in the top phase, I used methyl isobutyl ketone. That's the organic solvent. And down in this bottom phase, I dissolved about 2.5 grams of uranyl nitrate. Depleted or natural will work. I'm not sure which one it is, but since it's mostly uranium-238, that's what we're looking for, because that's what uranium-238 will decay to, is this specific isomer here, which is an isomer is an excited state of an isotope. And normally, about 99% of the time, the Protactinium-234m will directly beta decay to uranium-234, and then the uranium-234 will alpha decay to thorium-230, and so on down the uranium decay series. So what we have here is we have uranium-238, and we have its great-granddaughter decay isomer, which is Protactinium-234m. Protactinium-234 has a half-life of about 6.7 hours, and that one's more trace, and also that's not the one what we're looking for. In this one, we're looking for the half-life of the Protactinium-234m, which it normally decays to. So you have uranium-238, which decays by alpha to thorium-234. Uranium-238 has a half-life of about 4.468 billion years. The thorium-234 has a much shorter half-life of about 24.1 days, and that beta decays to the Protactinium-234m. And then the Protactinium-234m usually just undergoes beta minus decay to uranium-234 with a pretty high endpoint energy of about 2.268 MeV. There's another one about 1%, and that one has an endpoint energy of about 1.224 MeV. So those are the hard beta particles that we're going to look for when we prime this generator here and set it under the inspector USB Geiger-Müller counter. So what I'm going to do is I'm going to go ahead and shake this, and that protactinium will move up into this organic layer here. So without further ado, let's get on with the demonstration. So I'm going to shake this for about 15 seconds. And that should do it. And we're going to flip that upside down so that the cap isn't in the way. I have an O-ring around it. It's leak proof, but might as well take some extra precautions since there are some volatile chemicals in there and corrosive chemicals. Right here I just have a cardboard box, let's go ahead and turn the detector on. As this is settling, this should probably be about ready. And we're just going to take this and we're going to slide that underneath the detector, and we're going to let it count. The numbers are what matter, by the way. I figured I'd talk so that you're not bored throughout the video. Backlight. Unfortunately, it only lasts 30 seconds. That's the maximum you can set it to. This hooks up to a computer via USB mini cable. This is a new Protect boot, which replaced the Extreme boot. And this is the newer, The black colored detectors had a firmware issue and a battery drain issue. So this is version 2.13. Even though this has been replaced by the Ranger, the SEI Ranger, it is still a great detector. It uses the LND 7317 Geiger-Müller tube, and that will detect alpha, beta, X, and gamma radiation. This also has built-in isotope efficiencies too, so you can measure different isotopes in decays per minute or becquerels. A becquerel is a disintegration or decay per second. Always use counts per minute or counts per second. And the reason why is because with an unknown isotope, you can get false readings. This is specifically calibrated to cesium-137, which decays by beta decay to barium-137m, I think about 94% of the time, and that undergoes isomeric transition to stable barium-137. And they also have generator kits for those as well, and I believe they're available pretty much worldwide. However, the Protactinium-234m generator is not. I usually only see those available in the UK and some other European countries. They're not available here in the United States. That's why I built mine. They're quite expensive, and I don't think they're available to the general public, so I figured I'd build one. They're not hard to make, but you want to be careful because uranyl nitrate is water soluble and it's highly toxic. And you have to work with hydrochloric acid, concentrated 37%, and that's a very corrosive acid. And you do not want to inhale that because the fumes that come out are quite irritating. The methyl isobutyl ketone, on the other hand, is usually the organic solvent used, although you can use amyl acetate. However, I use the methyl isobutyl ketone. It's a little more stable, and the great thing about it is it works a little bit better than amyl acetate. However, it's more flammable. So expect to use some pretty nasty chemicals if you plan on building these. And make sure you use a leak-proof bottle. I used polypropylene, which is pretty resistant to most acids, esters, ketones, etc. Teflon works the best in my opinion, but they're quite expensive. You'd be surprised at how expensive a bottle is. Just an empty Teflon bottle. This can go to the observer software on a PC, and you can actually plot a nice decay curve. However, if you want to go old school, you can get out graph paper, or you can use Microsoft Excel, and you can use a really nice, you can graph a really nice decay curve for this isomer. And Protactinium-234m has a half-life of, it's measured to be precisely or approximately 77 seconds. As you can see, the numbers have dropped significantly. But other than me talking, if you take the numbers here and plot them, you can get a nice exponential decay curve for this specific isomer. Radioactive trefoil here represents the center of the Geiger-Müller detector, which is very useful. Geometry is very important if you're measuring sources or counting sources. This also has pre-programmable efficiencies built into it too, and you can change those with the observer software, which is very useful. I have some lines here on this piece of paper to just signify where the center of the detector is. So, and then underneath there is a circle that's the same size as the GM tube. So you get a nice geometry when you're measuring sources. Well, that's about it. Let's drop to about background. Background here is about 30 to 40 counts per minute. The generator before it's primed is about 120 counts per minute. But yeah, that's the Protactinium-234m Generator. And it was fun to make, and it's great for half-life experiments. Well, that's about all, folks. Thank you for watching. Haven't made a video in a while, so I figured I would, a long time actually, so I figured I'd upload this one. I don't have a tripod, that's the one thing I need. I used to have it, but anyway, what we're interested in is the numbers. So thanks for watching.